Part 3. We are still combining rational functions, but now our denominators do not match. So, as we saw in the previous video in fraction land, we need our denominators to match. So that is our goal right here. Now, sometimes there's a lot of work that has to take place in order to get your denominators to match. In this particular set of questions, the work is pretty consistent. And so what's going to happen is this. Right now I've got two fractions, one has a denominator of 2, one has a denominator of 10. They do not match. What I want to think about is I want to think about multiplying two numbers or multiple things to get the second number, in which case we would see that in order to get 10 we would need 2 times 5. What that means is I need an extra 5 on my first fraction. So whatever I do to the denominator, if I want to turn that 2 into a 10, I need to multiply by 5. Whatever you do to the denominator, you do to the numerator. So that means this first fraction right here of 1/2 can be rewritten as 5 over 10, multiplying both the top and bottom by 5. My second fraction has not changed. My second fraction is still a 3 over 10. And then when I want to add those two fractions together, our rules from before apply the same. Denominator stays the same. Add the top, 5 plus 3 gives us 8, and we are satisfied. You might be able to simplify that fraction. Obviously you can pull a 2 out and rewrite it as 4/5, but even if you didn't, we have an answer. This is the logic we're going to use. Now, when we're dealing with our rational fractions, it's a little harder to figure out this 2 times 5, but it's nothing a little factoring can't help us do. So our first practice problem right here, I pulled this directly from the homework level, so you know it's a level of difficulty you can expect, and let's work our way through. I need our denominators to match, which means I need to turn this x plus 2 into x plus 5, x plus 6. But in order to do that, I have to factor this first part. Now here's where it gets kind of fun. Remember factoring. I want to turn this into two sets of parentheses multiplied together. Now here's the deal. You still can make the box. You can still make the diamond. You can factor like normal. However, just for the sake of simplicity, guess what this x plus 2 is? It's going to be one of your factors. So now I want you to think for a second about realizing that you need to turn that 2 into a positive 6. Well, that only leaves you one option of positive 3. And we can double check. 2 times 3 is 6. 2 plus 3 is 5. So what that means is if I'm going to turn this first fraction, in order to have the same denominator, I need a factor of x plus 3. So I'm going to include an additional factor of x plus 3. Whatever I do to the denominator, I have to do to the numerator. Okay? Here's where we got to be a little careful for these problems. I'm now going to rewrite what we have. So, our second fraction is unchanged. 4x plus 10 over x squared plus 5x plus 6. Our first fraction now has the same factors, x plus 2, x plus 3, x plus 2, x plus 3. So I can jump straight to x squared plus 5x plus 6. Where I need to be careful is with my numerator, because this x is now going to each piece inside of my parentheses. So now I've got x times x is an x squared, and x times 3 will be a plus 3x. Now I'm going to combine the previous two activities. I can add my fractions together because they have a common denominator, and when I do that, I simply need to combine like terms on the numerator. So when I combine these, the denominator does not change, x squared plus 5x plus 6. And now for the numerator, I'm going to combine like terms. So I've got an x squared right here with no matching squared part on the second half. I've got a 3x and a 4x that combine to make 7x. And then I've got a plus 10 with no matching part on the first half. And there be my final answer. Now, in case you're curious, this is an acceptable answer. You may submit that for this problem. Out of curiosity, just as a little hint, I'm going to see if we can reduce this guy. So we know the denominator turns into x plus 2, x plus 3. Let's think about the numerator. Two numbers that multiply to 10 add to 7 is also x plus 2, x plus 5. 2 times 5 is 10. 2 plus 5 is 7. So in other words, technically, you would be able to cancel those factors out, and you could have an ideal answer, or simplified answer, of x plus 5 over x plus 3. This part in red is not required, but sometimes it is nice to be able to clean up your problems a little bit at the end. You should be able to submit this so long as you include your extra parentheses around the numerator and the denominator. But if you want to do the practice, I do encourage you to do this. It's not too hard to do the extra factoring step. With that, I want to look at one more that's the same idea, but subtraction. So, same thing, we need to get our denominators to match. So when I look at this x squared minus 1, when we think about factoring, our mind should hopefully jump straight to difference of squares. And I now know that this is x minus 1, x plus 1. So starting off with that now means I need an extra factor of x plus 1 so that my two denominators match. X minus 1, x plus 1, x minus 1, x plus 1. I can then, whatever I do to the denominator, I must do to the numerator. I've got an x plus 1 right here. Now, this one's a little bit more involved. Oh, did I just screw that? No. Sorry, I had a second guessed myself on the last problem. So now, we come in and let's set this one up. So, starting off, second one doesn't change. 5x plus 7, and then x squared minus 1. We now know the numerator or denominator for the first one's going to match because they got the same set of parentheses. Now this numerator up here, I now have two parts, and I want to make sure I multiply those together. So just for the sake of clarity, I'm going to come over and I'm going to make the box because I need to multiply x plus 5 and x plus 1. So when I multiply those together, x plus 5 and x plus 1, I have an x squared. X and 5 make 5x. X and 1 make 1x. 1 and 5 make 5. And so I get an answer of x squared plus 6x, combining those two boxes, and then a leftover 5. So my first numerator will be this chunk right here, x squared plus 6x plus 5. Same as before, I am going straight across, so I can just keep the same denominator, x squared minus 1. I do need to be careful of this subtraction piece right here. So here's what I'm going to do. I'm going to change it to addition, and then I'm going to change both signs of the next part. So I've got an x squared that's going to combine with nothing, so it's just left over on its own. I've got a 6x and a minus 5x, which is going to give me a plus 1x. And then I have a plus 5 and a minus 7, which is going to give me a minus 2. And if I wanted to try to simplify this one like I did in the last one, well, I think we can quickly see that the top value or numerator isn't factorable because 2 has to be 1 times 2. And, oh wait, positive 2, negative 1? Maybe this one factors too. Let's think about this for a second. So two numbers that multiply to negative 2 could be x plus 2, x minus 1. 2 times negative 1 is negative 2. 2 plus negative 1 is positive 1. We saw that as our difference of squares, x plus 1, x minus 1. Sure enough, those cancel because they're the same. This does have a simplified form, x plus 2 over x plus 1. Cool beans. So both of these did simplify. It's not a guarantee that that will happen, though I'm thinking it might be actually because of the way I coded the question. I'm not 100% sure. Anyways, this is acceptable. Whenever you're doing these problems, make sure you multiply out your parentheses carefully. Also make sure that when you're subtracting, you make sure that negative sign goes to both parts. And there we go.